Hello everyone, welcome to the Introduction to Lab for the week of October 26th. And we will be doing two exercises out of the fourth edition of Contemporary Activities in Astronomy by Hoff and Wilkerson. For those of you who aren't in the class who might be watching, we'll start by talking about exercise 9 here, Kirchhoff's laws and spectroscopy. This is a fun lab. So what you're going to do is this one follows what we do here. Will follow the instructions in the lab book less than many of the others that we do. And so what you're going to do is I want you to look at the spectrum of a lot of different objects. So each object has its spectrum, and you'll observe it with the handheld spectrometer that we have right here. And I'd like for you to record a few things for each of these objects. And the objects, you'll look at them. And so it kind of follows this sheet here that's on page 91 of your lab book. So we're kind of following this sheet. But you can think about where it says general color out here. So these are the things that I want you to write down for each of the objects that you look at. So just give me a description of what it looks like to your eye. What color is it? What is it? How does it appear to you? Okay, so these are the things that you're looking at right there to give me a general description of each object. Then I want you to give me a description of the spectrum, and you're going to do that a few different ways. I want a word description. So write me a sentence or two telling me what the spectrum looks like. 2, I want you to sketch the spectrum, how it appears to your eye in the spectrometer. So, for example, if there is a region that is continuous and a few bright lines, it might look something like that. And you should label on here what the relevant wavelength ranges are. 700 nanometers, 550 nanometers, label what these are, and so on. But then what a spectrum really is, we like to think about our spectrum as a graph of intensity. It is an intensity as a function of wavelength. You got wavelength down here where it's brighter, it's more intense. So I would like you to sketch me. So you're sketching the appearance here. But I'd also like you to sketch the graph of intensity versus lambda, the wavelength. So it might look something like this. Intensity up here, lambda down here. If it's continuous, continuous. If it's continuous with dark lines, maybe you see regions where, these narrow regions where it's less bright. Maybe it's bright lines. You see individual spikes in the graph. So I want you to think about being able to describe a spectrum that you observe in 3 different ways. Describe it in words to someone. You're writing a letter to someone. What does that spectrum look like? Sketch the appearance of the spectrum, but then turn that appearance into a graph. Of intensity versus wavelength. And I want you to do this for a number of different objects. And those objects will include the fluorescent light, like in the lab or in the hallway outside. So what does it look like for the fluorescent light? 2, what does it look like for an incandescent bulb? At 3 voltages. I'll walk you through how to change those in the lab. At 3 voltages, I don't know, 40, 80, 120, I don't care exactly. If you want to have slightly different voltages than that, 30, 70, 110, whatever you can see, whatever works really well for you. Then you've got a series of gas lamps. lamps that have different gases in them. And so a series of gas lamps. And then some unknowns. You got two unknowns I'd like for you to try to identify. We'll talk more about that in lab as well. So two unknown gases. There's probably in this series, if I remember correctly, I just set it up downstairs. If I remember correctly, there's probably 4 different gases, maybe 5 of these. And then, there's color bulbs, green, blue, and red. What do those look like? And then the sun. We won't, of course, look directly at the sun, even with our spectrometer, but we'll look at a bright patch of sky near the sun. And we'll talk about how to use your spectrometer to do that. So we want to look at the spectra of all of these different things and record them, as we talked about a moment ago, by describing what we see, by drawing a sketch of the appearance of what we see, and by turning that sketch into a sketch of a graph of what the intensity as a function of wavelength would look like. So I want you to try to identify, I want you to do all of that work, try to identify these on the charts that are downstairs, write a little short summary of the kind of things that you're seeing here, and I want you to answer discussion questions 1 and 4. So discussion questions 1 and 4 at the end of the lab. Remember now, we talked about this in class last Friday. Remember that the spectra, there's sort of 3 different types we talked about. If you've got a tenuous gas, then you would expect to see an emission line spectrum. If you've got a solid or liquid on the surface of the Earth, a dense object, then you would expect to see a continuous spectrum, all of the colors in there. If you've got a tenuous gas in front of a dense object, you have all of the colors, and that tenuous gas removes some of those colors, and you see an absorption line spectrum. You see darker lines on top of the brighter background. Now, it is possible to actually see bright lines on a bright background. If you had a really hot gas that was emitting a lot of line emission, you can see that projected against a continuous background. You don't see that very often, but you might see that in regions of stuff that we're looking at here. So as you take the spectra of each of these things, as you observe the spectra, be thinking about the physical nature of each of those things. What is the spectrum telling you about the physical nature of what you're observing right there? So I want you to write me a paragraph of all of this observing and what you're seeing, like we typically do. So you write me 1 paragraph describing how this goes. I want you to draw me all those sketches and word descriptions of each of the things that you see. Answer discussion questions 1 and 4, and that's good for that lab. The spectrometer, we'll go through this a little bit more in lab. Spectrometer looks like this. This is where the light comes in, and this is the part you look through. There's a scale. When you look at it, you hold this up to your eye and you look. There's a scale, and it's got 700 nanometers on the left and 400 nanometers on the right. So you should be able to see the spectrum of whatever you're looking at projected against this film here. And the film has the wavelengths on there for you to be able to measure and to record on the diagrams that you're drawing. Some of these have this diffraction grating that you're looking through to split the light into different colors. Some of those are glued down still, and the orientation is great. Some of those, they're not glued down, and you have to rotate that disc. So you might see the spectrum in there at an angle relative to your scale, and you need to rotate that until your spectrum is aligned with the scale. So you can see the bright band of colors with the scale. Now, one of the things that you also want to do is whatever your light source is, suppose that this phone is my light source. I don't want to point the broad part, the scale part at it. I want to point the narrow hole, the square hole aperture at it like that. So it looks like that, not like this. Okay, so with all of the lamps, you want to get pretty close to them all of the objects that we're looking at. I don't think you can probably get too close to the sun, but you want to get pretty close to all of the other light sources as close as you can, and make sure that you're pointing this square aperture at it more so than this. Sometimes if you have a bright background, like with the sun, it really helps to block some of that background light. You can do it with your hand. So you're letting the light come through the square aperture, but not through the film. Or you can do it, we'll show you by leaning against part of the building so that the bricks of the building, for example, block the light that's coming through here, and you get the light that comes directly through here. So we're going to work with these tomorrow. Think about what you want to get done here, and start with looking at the spectrum. You can do these in any order. Do the sun last or next to last or near last or something like that, because it's a little trickier to see. And so you want to practice using this device before you go looking at the spectrum of the sun. And also, you probably want to do the fluorescent light first, because when you look at the fluorescent light, there's a green line in there that should line up with a little tick mark that's on the bottom of your scale. And you can slide your scale back and forth. You can take a pencil and put it in this hole that's right there. So you put the pencil in that hole, and you slide the film back and forth to try to align that small tick mark, that calibration tick mark with the green line. And you have to move this very little to get that to move a lot. So just move it a tiny little bit as you do it. On the other hand, an alternative approach is to not even move the film at all. Just recognize that, like I'm looking at it right here, the green line is about 5 nanometers short of where it's supposed to be. So I should add about 5 nanometers to all of the measurements that I'm making of those lines. And so it's possible to do it that way without trying to do the calibration, but it's also possible to do the calibration, to take something like a pencil. This is not a pencil, and just put it in that hole and move it ever so slightly. And so you just want to tweak that film a little bit back and forth and see if it's moved it to where you want it to be. That's a little further away, actually. So then you just keep tweaking it around and see if you can shift that. This isn't quite strong enough to actually move that film. But that's the idea. That's what you're trying to get done here. We'll work with this tomorrow. So that's part 1 of the lab, exercise 9 from Contemporary Activities in Astronomy by Hoff and Wilkerson. And we'll also be doing 19. So look for that video very near you.